Now, for keynote speech, it is with great pleasure that I welcome Professor Martin Weiss. He is a professor of University of Pittsburgh and Associate Director of Center for Governance and Market. He will be a virtual keynote speech. Please give a warm welcome to Professor Martin Weiss.
Thank you, Professor Huang and Professor Char. I'm honored to have this opportunity to address this distinguished group. As an academic, I know that your intimate knowledge about the details of smart city deployment exceed mine. I hope that the more theoretical and broader approach that I can offer stimulates your thinking and enables you to improve what you are doing on the ground. Professor Huang asked me to speak to the topic of leadership in smart cities. As you know, perhaps better than I do, this is a topic that has many dimensions. For my remarks today, I will focus on one of these. How do you decide about which investments to make? I'd like to begin by briefly situating the context as I see it, because it has implications for the kinds of investments we must make. While this is probably not surprising to you, I think it is important to my argument. The main thrust of my comments have to do with the idea of optionality and what that means for smart city leadership. In setting the stage, I would like to begin with the observation that cities are not monolithic entities. They are collections of neighborhoods and districts, each of which can have unique features and attributes. These features may consist of unique infrastructure, geographic characteristics, and cultural characteristics, among others. In many American cities, for example, individual neighborhoods were identified with their immigrant groups. In Pittsburgh, we have a neighborhood called Polish Hill, which was settled at one time by people from Poland. We have the Bloomfield district, which was settled by people from Italy. Deutschtown was settled by people from Germany. And there are other districts as well that were home to different European immigrant groups. Over time, this has gotten more complex, where we have different language groups. We may have Chinese speakers. We may have Spanish speakers that are concentrated in different areas. And this is, again, it's a moving target in American cities. So these boundaries aren't fixed. And in fact, there are many overlaps between these different regions. This kind of brings us to the idea of polycentrism. Polycentrism just means that we have multiple centers of responsibility that may overlap. This recognizes different governance regimes that we may have. Again, in American cities, we may have a city government, we may have a county government, we have a state government. We also have different regimes over the top of that, maybe neighborhood communities that get together to define things. This appears to be chaotic and disorganized, but thanks to the pioneering work of Vincent and Eleanor Ostrom, in the 1950s and the 1960s, we were able to see that even though it looks chaotic, it's often a more effective way of delivering citizen services than a more organized, centralized approach. So we shouldn't reject polycentrism just on the basis of being chaotic. Furthermore, the development may be path dependent. So there's not a straight line that gets there, and every path will result in a different outcome. The next thing I want to say is that smart means different things to different groups of people. Governance groups and city officials may be interested in, for example, information collection and data processing to support efficient operations of a city. An individual citizen, by contrast, may be more interested in getting their street cleaned or ensuring that parking is available. People in other areas may have a greater interest in public safety than in some of these kinds of things. So when we talk about the word smart, we may well ask the question, smart for whom, and for whom the intelligence exists. I don't want to wade into the debate of exactly what we mean by a smart city. We are all here, I think, because we have at least some kind of an understanding of what a smart city is. For the purpose of this talk, let's just say that a smart city is a dynamic information overlay on a city that consists of sensors and significant information processing engines. And that the purpose of all of this is to support decision-making for individual citizens in the city, as well as for the operations of a city. So given that we have to build sensors of some kind and an information processing infrastructure, it's appropriate to consider smart city as an infrastructure, at least in part of as an infrastructure. What this means is that investments must be made in advance of services being delivered, which means that it's difficult. We have a lag between the investment and how the investment is used. The second thing that's often true about infrastructures is that they're an intermediate product for many other different goods and services. So we consider, for instance, roads. Roads is a well-known piece of an infrastructure. Well, I mean, roads by themselves are not particularly interesting. What they're interesting, though, is that they provide us with a means to other ends. It's a means for us to get to work. It's a means for us to visit friends. It's a means for us to deliver goods and services. And so it's an intermediate product rather than an end product. So because of this, infrastructures are often invisible. Invisible not in the sense that you can't see them, but invisible in the sense that we overlook them and we don't think about them until they break. We assume that they exist. And so because of this invisible nature of infrastructures, there's often a problem in making sure that we get sufficient investments for them. So what does this mean for you? Well, first of all, concrete investments have to be made before the use cases are fully understood, especially with a new technology like smart cities. And I'll talk a little bit more about that later. The other interesting thing about this, like a lot of new technologies, the use cases that we have co-evolve with the capabilities and characteristics of the infrastructure themselves. That means that users don't exactly know what they want until they see it. And as a system developer and a system provider, you can't really fully form the investment in the infrastructure until you understand what users want. And so once you understand what they want, you make changes in the infrastructure. When the infrastructure changes, what people want can change as well. All of this suggests, together with the diversity that we see in a modern city, that a single approach may not be aligned well with the diversity of a city. So we're kind of setting up this idea that maybe a central planning approach may not be 100% what we want to do. So we can learn from other systems. So for instance, if we take computer networking, in the 1980s and 1990s, there was a large effort in the computer industry that was led by the leading computer companies of the day to develop a series of standards that are referred to Open Systems Interconnection, or OSI reference models. These standards were intended to address the market concerns of the day. And notably, they were thought to be so-called anticipatory standards. They were standards that were developed in advance of the actual technology being deployed. And there are reasons for doing that, and that would be a conversation for another time. At the same time, really literally at the same time in a different technological environment, the US Department of Defense had started investing in computer networking technology as well. What they needed was a completely, they needed a robust environment. They needed a communication protocol that would succeed, that was highly survivable. So that would succeed under diverse operating circumstances. And unlike OSI, which was based on anticipatory standards, TCP systems were based on what they call rough consensus and running code. That means it was very implementation oriented. So we had in TCP/IP a system that was very much oriented towards developing standardized working systems, but with a high bias towards decentralization. So the Common Core investment was minimal, and it wasn't broad. Well, if you look at your computer today, you see that it's not running the OSI reference model. Instead, it's running TCP/IP. And so TCP/IP was clearly the successful outcome in this. And one of the main reasons why it was successful, there were a couple of reasons actually. One of them was that it was operations oriented. In other words, in the late 1980s, when the microcomputer revolution was really starting to take over and people wanted to network systems, they could get TCP/IP systems. The code was available. I mean, there were some problems with it, but they could be ironed out. It was all open source. The second thing about TCP/IP was that services were built around the edges of the services. So just as a way of example, we went through a couple of different iterations of information sharing services before the World Wide Web finally settled in as the way to go. Some of you who might remember Weiss, W-A-I-S, there was Gopher, there were anonymous FTP services. I mean, there were a bunch of different things that were tried. The web was by far the most seamless one. We also went through several different varieties of social networks. There were computerized bulletin boards. There were these proprietary so-called walled garden systems like AOL, and so on. So we went through a couple of iterations until Facebook and Twitter finally emerged. So the focus on interconnection rather than kind of enabled local organizations to make investments that were optimized for the local community without sacrificing connectivity to other communities. So again, we could spend a lot more time talking about this, but I don't have that kind of time in this talk. So let me move on to talk about local area networks. Local area networks were developed in the late 1970s. The standardization community began by looking at the Ethernet standard that was brought forward by Xerox and Digital Equipment Corporation and Intel. Ethernet, as many of you may know, has particular characteristics that may not meet all applications. And so there was a deadlock in the local area network communities because nobody could agree on how the system should perform. So the committee resolved this by essentially forking the standard into different approaches. And some of you may remember back in the 1980s and the 1990s, we could buy local area networks based on Ethernet, on token ring, on token bus. There were a variety of things that emerged. In fact, the wireless Ethernet that we are all using today didn't occur until much later. But the architecture, this decentralized type of, or this architecture that was developed for the local area network standards allowed this to emerge and allow this to thrive. Why did this occur? And again, you know, without kind of ruining the punchline here, we have given up using token ring and token bus some time ago, except for very specialized applications. And Ethernet, it was really the one that was successful. Does that mean that Ethernet was the best? I'm not comfortable saying that. What I will say, though, is that Ethernet was generally good enough for most applications. And most importantly, Ethernet was the first standard to get custom integrated circuits for it. And so the cost dropped radically. So it was inexpensive and good enough. And so it ended up dominating. Finally, another example that we can learn from, if we look back into the last 20 years or so, maybe a little more, 30 years, as computers began to become important, we had ambitious projects for building complex IT systems. The US government had some, we saw commercial companies have very ambitious projects to integrate these things. And there were some colossal failures. There were failures in the sense that systems became much more costly to build and took longer. And when they were delivered, they failed to meet end user needs. And so what happened was, as a result of that, and the analysis of that, was that it kind of focused on this coevolution problem that we've already talked about. We needed to have users adjusted their expectations as the system was being developed. And so we began to see new approaches to system development, like rapid prototyping and Scrum and Agile and other kinds of things that allowed these systems to evolve in a very different way to avoid these costly failures. So what can we learn from all of this? Well, one thing is that modularity allows for dynamic flexibility of investment and use. So we can, by modularizing systems, we can relatively easily customize them. Adaptability is really important to meet user needs. Systems fail if they're not adaptable. And then the ongoing evaluation of system suitability is important because it guides future development and it guides future investment. So from a more technical way, a lot of these things point to this idea of optionality. So with new technologies and new systems, user expectations and systems can evolve simultaneously. As I said, users don't really know what they want until they see it. And once they see it, they imagine what else can be done. And so people want choices. They want to be able to evolve. And you as a system developer want to give people those kinds of choices. We see this in these information system development approaches that I talked about just a moment ago. The main thing here is that these approaches allow dynamic adaptation of user expectations and technologies. So the idea of optionality is rooted in financial options. Financial options give us the right to buy or sell an asset at some time in the future at a specified price. Notice that this is a right. It's not an obligation. It's not a contract. It turns out that options can be very useful for risk management. If you're interested in exploring this further, Nicholas Nassim Taleb wrote a book on this called Anti-Fragile, where it's a more complicated read than just that, but he gets into the way in which options can work. So financial options are fine, but this needed to be translated into something that was useful for investments. And so this idea of real options came along. And so a real option is an option where the underlying asset is not financial, but it's actual. For example, oil in the ground, or perhaps real estate. With real options, these kinds of rights, instead of buying or selling an asset, were reframed so they'd be more useful for investment purposes. So we could have an option to delay an investment, for instance, or the option to expand and the option to contract. With real options, we can value those. And so we end up with a decision-making framework that allows us to explicitly engage with uncertainty that's built into the system. So getting back to smart cities, actually getting back to networks, there was a paper, I guess now 20 years ago, which I had the occasion to revisit. This is a paper written by Mark Gaynor, Scott Bradner, and others. In fact, Gaynor and Bradner have written in this time frame, wrote a number of papers that dealt with the thought option services. So in this particular paper that I have referred to on this page, they included this figure. And I thought this one was useful for thinking about smart city infrastructure. So when markets, if we look on the left side of this figure, when market uncertainty is great, we should invest in relatively small fixed core infrastructures and allow a lot of flexibility on what gets done with those. As market uncertainty decreases, as it happens with learning, as we try different kinds of services utilizing this core infrastructure, for instance, the uncertainty decreases. We understand what users want to be able to do, what different classes of users want to do. And when we do that, we can bring more into the stable core. So in the networking world, again, it's an area that I know perhaps better. When we started out with the internet, we didn't know exactly what we wanted to do with it. So David Clark famously said that we were building a network, but we didn't know what we were building it for. And what he meant by that, I mean, it's actually a funny statement in English, but what he meant by that was that there was no application, no particular application in mind for that. In contrast with the telephone network, in the telephone network, it was a network that was built for delivering calls. We used the telephone network for lots of things. We used it to send images on fax machines. We used it eventually to with data modems to connect computers together. But in each one of those cases, we had to make the telephone network think that it was connecting a voice call, because that's what it did. The transition to the internet moved us away from that. So we didn't know, for instance, that we wanted email. We didn't know that we wanted to be able to transmit video. We didn't know we wanted to share information and so on. And so we had to build We had to try a lot of different kinds of services. As for instance, the services, as we got a better idea of what we wanted to do, let's say streaming video, more of these things got pulled into the core. So for instance, nowadays, we have content delivery networks that pull, that move data closer to the end user so that the performance is better and so the load on the network is worse. And that's essentially become a core service to the internet. So what does this mean for you? It means that you should be planning your investments for adaptability. What you focus on as being core should depend on how stable, how clearly you understand the need for that information. And the dimensions of this adaptability is multidimensional. We can have temporal adaptability, that is, we change over time. We may want spatial adaptability, so we change over space. And so, in other words, one neighborhood may not need exactly the same services as another neighborhood based, for instance, on topography. Or we have cultural adaptability. Different communities within a city may have different needs. So we may have needs for smart city services in different languages, for instance. Framing your investment decisions through optionality may be helpful because it allows you to explicitly value flexibility. And so you may be able to make better long-term investments. And finally, and this is not something I've talked about a lot, was building a path for sustainable investments. So there's a lot of enthusiasm initially for making investments, but if those aren't sustained over time, then the infrastructure will collapse. And so you can do this by connecting the intermediate product aspect of the smart city investments with the social goals that a city or a country may have. It's also important to address equity within a city because equity, one of the criticisms for a lot of the new smart city deployments is that they tend to be biased towards wealthy communities. So what do I want to leave you with? First, remember cities are not monolithic. I know that you know that about your city, but because they're monolithic, should smart city systems be monolithic or not? I mean, I tend to think no. I tend to have a bias towards liking these polycentric and adaptable approaches. The uses of smart city technologies co-evolve with the technology investments themselves. And so the idea of optionality allows you to incorporate that explicitly into your investment strategy. And I think that this is a useful framework for modeling smart city investments. So just a brief statement about the Center for Governance and Markets. This is a new center at the University of Pittsburgh where we want to analyze topics like these. We analyze them from a bottom-up perspective. We do this through a network of global partners. And in smart cities is one of the topics that we are concentrating on, and in particular, we want to understand how rules that affect the ability of communities to engage in collective action. So if you're interested in what the Center for Governance and Markets does, please click this website. So I want to thank you for your attention. I would much rather have been there in person to discuss these matters with you in greater detail, but that was not possible. I would like to give you the opportunity to engage with me, though. If you have any questions or would like to discuss this further with me, please reach out to me at this email address. Thank you again, and I wish you a productive and engaging meeting.